Hello everyone. Once again, I welcome all of you in my YouTube channel. Our today's topic is based on 10th standard important topic, that is Kepler's law of planetary motion. This is very important topic for class 10th. Okay. Now, this topic I've taken from the first chapter, gravitation. Okay. So first we'll start with the introduction of Kepler's laws of planetary motion. Before that, those who are new on my channel and it has not subscribed, kindly subscribe my channel and share, and also click on the bell icon so that you can get latest notification of all my new upcoming videos. Okay, so let's start with this. So my dear students, planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of the planets' positions were made with naked eyes. By the 16th century, a lot of data were available about planetary positions and motions. Then Johannes Kepler studied this data. He noticed that the motion of planet follows certain laws. So who has given this? A German astronomer, Johannes Kepler. Okay. He stated three laws describing planetary motion. These are known as Kepler's laws, which we will discuss in this session. Okay. So let's start. Now students, before going with further explanation of Kepler's laws, first we need to understand few things. Like in circle students, we have a center and this center is called as the focus. Similarly, in the ellipse, we have two foci. Okay, the foci of the ellipse are the two reference points that help in drawing the ellipse. The foci of the ellipse lie on the major axis of the ellipse and are equidistant from the origin. An ellipse represents the locus of a point, that is the sum of the whose distance from the two fixed points are constant value. Okay, I hope this is well understood. Now, let's start with the further introduction. See, when we are saying Kepler's law, the first law basically it says the law of orbits. Second law is based on the law of equal areas. And third law is based on the law of periods. In further session, we'll discuss each law in detail. Okay. Okay, so let's start with Kepler's first law. Okay, first law, it states the law of orbit. Okay, so what is first law says that? It says that planets revolve around the sun in an elliptical path, in an elliptical orbit. All the planets revolve around the sun in elliptical orbits, having the sun at one of the foci. And where the sun is located? It is at one of the foci. Okay, so it's very simple. All the planets revolve around the sun in elliptical orbit, having the sun at one of the foci. Okay, now next important student, the point at which the planet is close to the sun is known as the perihelion, and it is about 147 million kilometers from the sun. And the point at which the planet is farther. Okay, for an example, I'm taking the second point over here. After some period of time, the planet is here. Correct? So at the point where the planet is farther from the sun is known as the aphelion. Okay, once again, the point at which the planet is close to the sun is known as perihelion, and the point at which the planet is farther from the sun is known as the aphelion, and aphelion is about 152 million kilometers from the sun. Okay, so basically it is a characteristics of an ellipse that the sum of the distance of any planet from two foci is constant. Okay, I hope this is well understood. So let's start with the Kepler's second law, that is law of equal areas. Now what Kepler's second law says that? It says that the radius vector drawn from the sun to the planet sweeps out equal areas in equal interval of time. Now first of all, what is radius vector? Suppose the sun is at this point and the planet is at this point. So the line drawn from the sun to the planet is known as the radius vector. Correct? Now, this sweeps equal areas in equal interval of time. That means consider karo students. Suppose sun is at this foci now. Initially the planet is at this point. Correct? Planet kahan pe hai? Yahan pe hai. Now, after 1 month the planet is reached at this point. Consider P prime. Correct? So this much area is covered by the planet. Correct? And now consider after 4-5 months, or we can say few period of time, the planet is reached at this point. Correct? And then again let's see for 1 month. So again it will cover some area. It is covering some area, planet with respect to sun. Correct? So the area covered in the interval of 100 months will be exact equal. Correct? So therefore second law says that the radius vector drawn from the sun to the planet sweeps out equal areas in equal interval of time. Correct? And the main important over here, student, as the orbit is not circular, the planet's kinetic energy is not constant in its path. Okay? It has more kinetic energy near the perihelion and less kinetic energy near the aphelion. Implies more speed at the perihelion and less speed at the aphelion. Okay? So, if student, r is the distance of the planet from the sun at perihelion, that is we can say r minimum, and aphelion r maximum, then we can write r minimum plus r max is equal to 2a into length of the major axis of an ellipse. So basically second law says that the area swept by the planet will be equal. Okay, in equal interval of time. So now move to the Kepler's third law. What third law says that? Basically it is based on the law of period. According to Kepler's law of period, the square of the time period of revolution of a planet around the sun in an elliptical orbit is directly proportional to the cube of its semi-major axis. So students, this is this major axis, this is minor axis. Half of the major axis is known as the semi-major axis and half of the minor axis is known as the semi-minor axis. Okay. So semi-major axis is represented by A. So complete, if we are saying major axis, so it will be AA, that will be 2A. Correct? Minor, we are representing by B. So complete minor will be 2B. Correct? So basically, this T is square directly proportional to AQ. What is T? T is the time taken by the planet to complete one revolution around the Earth. If we are talking about the Earth, so Earth time period is about 365 days, that is 1 year. Okay, so it is directly proportional to the cube of its semi-major axis. Okay, and the main important is the shorter the orbit of the planet around the sun, the shorter the time taken to complete one revolution. Okay, I hope it is well understood by everyone. So I hope all these three laws is well understood by everyone. So let's just recall once about these laws. Okay, the first law, Kepler's law, says that the orbit of planet in an ellipse with the sun at one of the foci. Second law says that the line joining the planet and the sun sweeps equal areas in equal interval of time. And the third says that the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. For any doubt, Please put your comment in the comment section box. Thank you very much.